So what happens as you see from class A to class C? Can somebody summarize what happens as we move from class A to class C? What is increasing, what is decreasing? Can anybody say? Can anybody say? As we move from class A to class C amplifier, what is increasing and what is decreasing? Yes. What parameter is increasing for class A amplifier as you move from class A to class C, and what parameter is decreasing? The slide is on the, you are seeing the slide, you can even say from that. Nobody is there in the class. Shall you wind up the class? No use, sir. I am talking alone.
Theoretical is maximum. Conversion efficacy is 25%, so it is increased to 50% by using transformers, which is in the case of class A. And
In general, you say, in general, what is happening to efficiency as you move from class A to class C?
efficiency increases.
Increases. What is decreasing? What is reducing?
Power loss.
Amount of time.
Amount of time the transistor is conducting is reducing, correct? So can you say about which amplifier is highly linear, which amplifier is highly non-linear? Class A is linear or class C is linear? Or class A is non-linear or class C is non-linear? Can you come to a conclusion based on these results? Which amplifier is the most linear amplifier? Which amplifier is the least
Class C is
linear?
the most linear.
Class
C, sir.
See, the class C, it is operating only for 25% of the time. So it is not even 1/4 of your time, it is active. So if the transistor is active only for 25% of the time, will it be able to reproduce the entire signal, whatever you give at the input? See, your input signal is 100% of the time, but the transistor is operating only for 25%. So only 25% of signal will be amplified, right? So what will happen to remaining 75%? It will be skipped, it will not be amplified. So in that case, can you call class C as a linear device? So what is the meaning of linearity? Whatever I give at input should be available at the output in the exact way or in the amplified way. So which amplifier is that? See, class A amplifier is conducting for 100% of the time. So whatever input you give will be available at the output in an amplified way. Class B is working only 50% of the positive half cycle will be amplified, negative half cycle will be completely removed from the input. Class C, it is less than 50. So positive half cycle, only half of positive half cycle is amplified, negative half cycle and remaining half of positive half cycle is completely cut off. So you can see as you move from class A to class B, the linearity is reduced. It is slowly becoming non-linear. From class B to class C, it is becoming highly non-linear. So which amplifier is working for 100% of time? Only those amplifiers are linear. So if you go by that logic, class A amplifier is highly linear. Class C amplifier is highly non-linear. Is this conclusion justifiable to everybody? You're able to understand why we are making this statement here? Because just because efficiency is high, you should not understand that the amplifier is linear. We are increasing the efficiency at the cost of linearity. You cannot compromise between efficiency and linearity. If efficiency is less, linearity will be very high. If efficiency is very high, linearity will be zero. So they are inversely proportional. Is this concept clear? So remember that class A amplifier is the only amplifier which is linear in this topic, whatever we are discussing. Other amplifiers are non-linear amplifiers. So we have to design this amplifier in such a way that the power conversion efficiency should be maximum and the power loss should be minimum. So this is the goal for any amplifier, right? So when you design any amplifier, your efficiency or gain should be very high, the loss should be minimal. Ideally, we say the loss should be zero, the gain should be infinity. But practically, you cannot measure what is infinity, right? So you will set a condition that practically the efficiency or gain should be maximum, and the power dissipation happening at the collector should be minimum. So this is the condition which we put forth for power amplifiers. Why this is very very important? Because the power amplifier will instantly generate heat, and that heat will be dissipated as loss. Okay, so that is the reason why we focus on two factors. The loss should be minimum and the efficiency should be maximum. So based on the what biasing we use, where you fix the Q point, what is the amplitude of input signal, we can classify the amplifiers as class A, class B, class A, B, and C. So four types of predominant large signal amplifiers are available in the market, and we are going to study about the four types of amplifiers: A, B, and